Today we're going to take a look at NGXS, a new state management library that reimagines the way the Redux pattern should be applied in Angular. It gives us a global immutable data store, then components can select data from the store as an observable, then dispatch actions to mutate the store. The end result is a circular, predictable flow of data that is especially beneficial for apps that have a complex data state. In this episode, we'll go through the basics of NGXS from the ground up. If you're new, make sure to like and subscribe, and grab the full source code from angularfirebase.com. So first, we need to address the elephant in the room. There's already a state management library for Angular called NGRX, which has become very popular by taking the implementation details of React Redux and applying them to Angular. But the problem is that Angular has a type system and makes heavy use of object-oriented programming, while React has no type system and makes heavy use of pure functions. In order to strong type everything and maintain a strict separation of concerns in NGRX, we have to write a ton of boilerplate code. Code that is often very difficult to read, especially for someone without an RxJS background. While I'm a big fan of NGRX and one of its top donors, I think NGXS addresses some of these concerns in a very elegant way. So what I've done for this video is I built an app with NGXS, and then I built the same exact app with NGRX so we can compare them side by side. The rest of this video will focus on the basics of NGXS, but occasionally I'll flip over to this NGRX app just so you can see the differences and how the code is implemented. And I'm not recommending one over the other, just showing you a comparison between the two. The app itself is called NGXS Salad Bar, and it allows the user to create and customize a salad order. If you look at the UI here, you'll see everything highlighted in green is saved in the App Store, and everything with a solid outline border is triggering an action. So you can see here we trigger actions that add toppings to the salad, and then it computes the price in response to those actions. To get started, we'll generate a new Angular app with the CLI, then we'll install NGXS Store, and also a couple plugins for development so we can use Redux DevTools or console log state changes directly in the browser. The next step is to go into the app module and import NGXS. You'll also notice that I've created a shared folder, which is where we're going to keep the app state and the router state. We're going to build these out later, but you can think of the state as a combination of an NGRX reducer and effect in a single class. Then we'll import the state classes here in the app module and add them to the NGXS for root, and then we'll also add our NGXS plugins here as well. Then just a quick side note, the plugin system is really awesome because it allows you to tap into the state changes and the action that triggered them to extend the library with your own custom functionality. Now, just to do a quick comparison, our app module in NGRX would look more like this, where we have a store module for root with a couple of reducers, and then an effects for root with the effects classes. Now, back to our NGXS app, we're going to build our first action. An action is just a class that has a type property and an optional payload. The only difference from an NGRX action is that the type property is static. Using a static property here is a clever way to reduce boilerplate because we don't actually have to instantiate an object, we can just pass in the class name when dispatching an action. Now I'm going to jump into the app state, and that's where all the action happens. The very first thing we'll do is model our data as an interface, which should look very familiar if you use NGRX. For the app state, we'll set a username, order ID, and a status. The next step is to drop in the state decorator, which replaces a reducer in NGRX. It's a class decorator, and we can strong type it to the interface that we just defined. Then we'll give the state a name, so we can slice it from the global store based on that name. So this will be our app slice, and we can also pass it some default values. In this case, I just give it an empty string and a random number as the order ID. So as you can see here, we now have a slice of the state that's clearly defined with default values. The next thing we'll want to do is listen to actions and then handle them as they're dispatched. For that, we have this action decorator that takes the action class as its argument, in our case, set username. Then you define a method to handle this action. The first argument in this method is the state context, which allows us to get and mutate the state within this method. In this case here, I'm going to use patch state to update a single property in the state without updating other items. Then the second argument is the action, which may or may not have a payload. In this case, it has the username as its payload. At this point, we want to update the current state with the new username, and we can do that by calling patch state with the associated data. In NGRX, normally you would compose a new object by using the spread syntax inside your reducer function, but here we're calling patch state, which does the same thing under the hood, but makes our code a lot more readable. And there's actually a few other tricks that we can do within the state context. Patch state will only update the properties that are specified, but if we want to update everything within the context of this slice of the state, we can call set state, and that will reset the state to the new specified object. We can also dispatch other actions from inside this action, which is especially useful when you start working with asynchronous data. And the other thing you can do is you can get the current state as a plain object. Let's say we want to look at the current user before we actually update their username. We just call getState, and that gives us this slice as a plain object. Now let's quickly run through a more concrete example. Let's say we have an action that navigates with the Angular router. First, we'll set up an action called navigate with a static read-only type, and the payload is the actual path that we want to navigate to. Then we'll set up our state to just be a string where the value represents the actual path that the user had navigated to. Then we can inject the Angular router directly into our state, which is a really awesome feature of NGXS. One thing that you really miss in a reducer function is the ability to use Angular's dependency injection. And yet another cool feature is that we're not just limited to observables. The Angular router returns a promise when we navigate, so we can actually just make this an async function, then await the router navigation and update the state afterwards. Async await provides huge gains in code readability and avoids the callback hell that you would normally have in an NGRX effect for dealing with a simple asynchronous operation that's promise-based. That being said, you can still listen to a stream of actions and handle them just like you would in an NGRX effect. What you're looking at here with this route handler is a stream of actions that is filtered to our navigate action. So you do have the option to do things the NGRX effects way if you prefer that, and there are certainly use cases for doing so. Now that we have all this code in place, let's go into a component and look at how we can select slices of the state and dispatch actions. Let's say we want to select the app state in our app component. The most familiar way to do it is to declare a property and then inject the store in the constructor and then call store select and use a callback function to select that slice of the store. So that's all good, but in a second here I'm going to show you a much better way to do this with an NGXS select decorator. But first I want to show you how you can dispatch actions. To do that, you can simply call store dispatch and then either pass in a single action or an array of multiple actions. In this case, we want to set the username and then navigate to our lazy loaded module. That's cool, but let's see if we can make some of this code magically disappear. Let's delete everything from the constructor, and instead we'll use the select decorator and then point to a property of app followed by a $sign. By convention, the library will automatically look for a property named app minus the $sign on the root store. And that's all you have to do to get observable data from the store. But if that's a little too magical, you can still pass a function in to select a slice as well. The next thing I want to show you is how to set up lazy loading, which is really easy to do with NGXS. After the user selects a name for their order, it's going to redirect them to a lazy loaded route and update the state with this new data. If we look at the app routing module, you can see that we have a lazy loaded salad module. In order to get this working, we just need to tell NGXS which state to use inside this lazy module. In this case, we'll call NGXS module for feature and then pass it the salad state for this lazy module. The implementation details for the lazy module are very similar to what we set up in the app, but I still want to show you how selectors work when we need to select complex slices of the state. This is common when you have to do things like client-side filtering, if you imagine you have an array and you want to sort it alphabetically or something along those lines. You can create a selector by using this selector decorator and then attach it to a static method. In this example, we'll just do something really simple like transforming the dressing property to locale uppercase. Now we can combine this static method with our select decorator in the actual component. If you remember, the select decorator takes a function, so we can just pass it our class followed by the function name, and then that will select that slice of the state in whichever format we want it. Let's go ahead and compare this code to NGRX. Building the selector will look something like this, with NGXS on the top and NGRX on the bottom. We have the functional approach on the bottom and the object-oriented approach on the top. If you look at how we select state in the component, you can see we get by with about 60% less code in NGXS. The last thing I want to show you is an asynchronous action in NGXS. Jumping back to the app component, we'll create a new action and pass it this confirm order action class. And then notice I'm passing this cancel uncompleted true option in the action decorator. I'll show you how this comes into play in just a second. Inside this action itself, we're going to first patch the state with an order status of pending. Then we'll return an observable that represents the async activity that we want to perform. That would most likely be an API call over the network. But in this case, I'm just returning a mock observable that has a 50-50 chance of returning true or false. Inside the observable, we'll pipe in the tap operator. If the observable resolves to true, then we'll go ahead and dispatch the order success action. Otherwise, we'll dispatch order failed. Now, if we dispatch this action, it's going to subscribe to that observable automatically. Normally, it would subscribe to every single one and resolve to a value, but because we added the cancel uncompleted true option in the action decorator, it's going to cancel all the previous requests automatically. That's a pretty common requirement when you have something like a type ahead where you're making multiple asynchronous API calls. And this is just one simple way that the library tries to make things easier for you. I'm going to go ahead and wrap things up there. If you have any questions or want to see more NGXS content, please let me know in the comments. Thanks for watching, and I'll see you soon.